Their map will document exactly how Venus and Earth differ. Then, they hope to find out why. Despite decades of exploration, our sister planet can still surprise us. And soon, Venus Express makes a stunning discovery. A spacecraft orbits Venus on a mission to solve a mystery. Venus should be like Earth. But billions of years ago, our twin went its own way and evolved into the burning rock it is today. While studying the outer edge of the atmosphere, Venus Express discovers the first clue to what went wrong. It detects particles escaping into space, mainly helium, hydrogen, and oxygen. Hydrogen and oxygen make water. For years, scientists debated whether Venus's atmosphere held any water. Some argued if early Earth had water, so did Venus. Perhaps enough to form an ocean covering 90% of the planet. Yet Venus Express detects only a small amount of water vapor in the atmosphere. If you condensed all that vapor onto the whole planet, it would create a layer of water barely an inch deep. If Venus once had a vast ocean, what happened to it? Most scientists once thought it simply boiled away. But as Venus Express orbits the planet, scientists are forming a new theory. They believe the culprit is still the sun, but the cause is more than simple evaporation. The sun sustains life on Earth. It also blasts out a constant stream of deadly charged particles. They race out at speeds of up to 1,800,000 miles an hour. It's called the solar wind, and it can devastate unprotected planets. Surrounding Earth is a magnetic field that safeguards our atmosphere. This field is formed by movement in our iron core as the planet spins. But Venus has no magnetic field. Scientists believe it may rotate too slowly to generate one. The rotation is so slow, a day here lasts almost 2/3 of an Earth year. On Earth, one rotation takes 24 hours. On Venus, 243 days.
Well, without a magnetic field like Earth's, Venus is much more vulnerable to being affected by the solar wind and by energy in the upper atmosphere, stripping the atmosphere off into space.
Scientists now believe a combination of evaporation and solar wind strip the planet of its moisture. Venus is closer to the sun than we are, therefore hotter. Its primeval seas evaporated into the atmosphere. That water vapor might still be trapped in the clouds, if not for the solar wind. Scientists can reconstruct how this could have happened with simple chemistry. First, the sun's energy splits the water vapor into hydrogen and oxygen. Then the solar wind smashes into the atmosphere, ripping the molecules from the clouds. Over billions of years, the water is lost in space. The oxygen and hydrogen detected in the atmosphere are the last drops of those ancient oceans. Loss of water turned Venus from a warm, wet planet to a burning rock. The atmosphere changed too, from water vapor to carbon dioxide. Ancient volcanoes released trillions of tons of CO2 and set off a chain reaction, a runaway greenhouse effect, leading to global warming gone mad. Earth's twin is now the hottest planet in our solar system, even hotter than Mercury, the planet closest to the Sun. Venus is the poster child for climate catastrophe, devastating global warming, and a cosmic hellhole. If Earth were nearer to the Sun, it would look like Venus. Life on Earth may be a lucky break, but in the end, we share the same fate. Scientists long guessed Venus was once like Earth. Venus Express has shown how it evolved into a barren world. More revelations lie beneath the clouds. On the surface, the clouds look calm. But when the spacecraft switches on its infrared thermal imaging spectrometer, its images show how the scene transforms. Violent storms rip across the planet. At the poles, monster cyclones churn the atmosphere. Storm systems that make Earth's worst weather look like a breeze. As scientists study this mysterious planet, they make a startling observation. While Venus rotates slowly, its atmospheric winds travel fast. Venus Express observes winds circling the planet in a mere 4 Earth days. That's 60 times faster than the planet's rotation speed. Scientists call this superrotation. If Earth were like Venus, winds would whip around the planet in just 30 minutes. A speed of 50,000 miles per hour. On Earth, wind speed nearly matches rotation speed. So why do Venus's winds travel so much faster than the planet spins? The answer lies in the clouds. On Venus, the cloud layer is up to 12 miles thick. So thick, only a small amount of solar energy reaches the surface. Much of this energy is retained in the upper clouds, 40 miles above the surface. This energy starts the clouds moving at breakneck speeds. Because Venus is closer to the Sun than Earth, the greater the solar energy in its clouds, and the greater the wind speeds. Winds rare on Earth, over 200 miles an hour, are typical on Venus. Scientists know the Sun powers Venus's winds, but they're still not sure exactly how, or how much solar energy it takes to produce superrotation. The data required to create a detailed computer model of Venus's atmosphere is beyond the capabilities of Venus Express. To further understand the superrotation winds, Kevin Baines from NASA's Jet Propulsion Laboratory proposes a mission for the future. Baines hopes to achieve the impossible. He intends to transport a balloon to Venus, inflate it, and release it into the atmosphere, carrying a set of scientific instruments.
We want to fly this up at around 30 miles altitude